Hi, this video is going to extend our knowledge of methods to a new idea called parameters. So to get this started, let's assume that we wanted to find out the length of the hypotenuse in a right triangle. So for those of you who remember from geometry, that if you have a right triangle, then a squared plus b squared should equal c squared. Noting that this symbol doesn't work in Java. So we're going to have to use a different symbol for exponents, but this is the general idea for the Pythagorean theorem. And we think that it might be a good idea to make a block for that. So I'm going to go ahead and make a new block down here. Public static void Pythagorean theorem. Seems like a good name. And then I'll just put in what I think I have. Let's say that I already know that one of the legs is 5, the other leg is 12, and then I'm going to do a little calculation to figure out what the other leg would be. So to do that, I'm going to have to use a couple math operations here. So I'm going to have to square A, that's the easiest way to do it, and I'm going to have to square B, add them together, but to get to my final value C, I'm going to have to take the square root of that expression, and the square root function always gives you a decimal, so I will have to store my result into a variable C, which is of type double. Now you could have used math.pow here as well, but A times A is simple enough. Alright, so as we've learned before, if I'd like to see something appear on the screen, I'm going to have to do a print statement, and then for this block to be executed, I would have to call the Pythagorean theorem method from the main block. So now if I compile this, and then if I run it, it tells me the correct answer, which is the missing hypotenuse is of length 13. Now, the problem with this block is that it's not very general. It only works for right triangles of length 5 and 12 for the legs. And if I needed to know that information, I probably would just store it. I wouldn't have to recalculate it each time. It would be more useful if this method would work on any set of legs and would be able to tell me what the hypotenuse is. And the way we're going to do that is we're going to move these two variables that we'd like to change in the future, not always be 5 and 12. And instead of having them here, we're actually going to put them up in the parentheses of the method. And I'm going to write them exactly the same, int A with a comma, then int B. And I'm now going to delete those two lines. And so what happens now is this is a general function. Instead of having a specific value of A and a specific value of B that we're hard coding in here, we're just saying for any A we put in and any B we put in, we'll do the mathematics. Now, there are some results of doing this. The first is our call in the main method no longer works, because when we call the Pythagorean theorem method, now we need some inputs. And those inputs should be, if we would like it to be as before, 5 and 12. And what this means now is that when we call the method, the number 5 will be copied into the variable A, the number 12 will be copied into the variable B, and then it'll execute our code and print out our result. So I'm going to try that, compile, and then run it. Still gives me the answer of 13. The nice thing is, now I could actually reuse this code, and if I wanted to do the Pythagorean theorem on a right triangle with legs of 3 and 4, now when I run it, it also tells me that the second triangle has a length of 5. So this is a very useful way of designing code so that it's reusable and so that it's general and can take inputs and will do whatever you want on those inputs. One final example I'll do is the distance formula, and I'm going to just copy and paste this block in. So here's a separate block. And you'll notice here that my distance formula block actually has 4 parameters this time. So you can have lots of parameters, as many as you want. And to do the distance formula, I'm going to use a nice little strategy from geometry, which is that when you have 2 points and you want to find the distance between them, you can construct a right triangle where the legs have links the distance between the x-coordinates and the distance between the y-coordinates. And so if I want to know the final answer of what the distance between those 2 points are, I just need to find the hypotenuse by using the Pythagorean theorem method. So to see this in action, if I would like to find the distance between 2 points, I could just do the following. Distance formula. Let's say I want to do the distance between 1, 3 and the point, who knows, 5, 7. That sounds exciting. So notice 4 parameters. So those numbers will be copied 1 into x1, 3 into y1, 5 into x2, and 7 into y2. Compile, run, and I get a decimal answer because hypotenuse oftentimes is, and it's 5.65 with a whole bunch of places. So that's the basics of parameters. They don't always have to be ints. If you want to have decimal inputs, you would put double here instead of int, and that would be totally fine. You can have as many parameters as you want, but you do have to write the type for each of these parameters that are here. So hopefully this made a lot of sense. Let me know if you have any questions.